Hi, I'm Chris, and in this module showcase I present to you the Playertron Boundary Reflector. First, let's have a look at this module as it is. Basically, it is a wavefolder. I have an upper threshold and a lower threshold, and if my input signal exceeds that threshold, it is folded back onto itself. Now let's go over the controls. We have already seen these sliders, with which I can set the upper and lower thresholds, or boundaries. Both of these sliders are CV controllable with their respective CV input checks at the bottom. This can lead to very interesting signals. I can quantize the slider positions to a note value with the Q note button, or to an octave value with the Q oct button. The octaves and corresponding voltage values are printed to the sides of this module. This is very useful if you want to process pitch signals, or if the output of the boundary reflector shall be used as a pitch signal. If I set the boundaries pretty close to each other, it can happen that the reflected signal exceeds the opposite threshold value. This is because the boundary reflector only folds once. I have the option to enable the limit bounds button to cut off the excess and limit the signal to the set range only. If the CPU is stressed, I can save on precious CPU cycles by disabling the visualizer with the Vis button at the bottom. Let's explore some possible applications of the boundary reflector. So here we have a basic generative setup. We have an LFO that provides a CV signal for a quantizer, in this case Septitone from Collider Modular, an excellent quantizer, and the quantized pitch signal is then fed into an oscillator, which outputs a triangle waveform. Now, as we can see, the output notes are all over the place, and some of them are even inaudible. So let's get a boundary reflector involved. With our first boundary reflector here, we have limited the voltage range from C2 to C4. But looking at the output nodes and the scope output, we can see that there are still some overshoots. Now we could enable the limit bounds function to limit the output to this range exclusively. But then, as you can see, a lot of nodes would get repeated at these limits. Alternatively, we can stack the boundary reflectors in serial so that the second boundary reflector deals with the overshoots from the first boundary reflector. And when the overshoots are dealt with adequately, we can enable the limit bounds to really nail this voltage range. And as we can see, this sequence is now very much more interesting than the first, and also only includes audible nodes. Of course, you can also use the boundary reflector as a literal wavefolder, a very flexible one. So in this patch, I have routed the output of the oscillator, the triangle wave, into two boundary reflectors. And the resulting waveform looks a lot more interesting than our initial triangle wave. Now, to go a step further, we can modulate the boundaries. Awesome. Naturally, there's a lot more that the boundary reflector can do. So have fun exploring with this awesome device from Playertron. Have fun, see you around.